Welcome to the finale of Stage 6, Lesson 30, and the last piece of the permissions puzzle. Meet Tom. Every time he runs touch to create a new file, it comes out as 644. Every new directory, 755. He never asked for those numbers, so who did? The answer is an invisible rule called umask, and once you see it, the whole permission system finally clicks. Here's the hidden rule. Linux starts every new file at 666 and every new directory at 777, then umask quietly subtracts itself from those defaults. With the usual umask of 022, that's 666 minus 022, Tom's 644, and 777 minus 022 is 755. The name mask fits because it masks out or turns off specific permission bits. And one quirk worth memorizing, files never get the execute bit, no matter how low you set umask. 666 is the ceiling. So let's actually watch this rule in action. Type umask on its own and it just prints your current value, here 022, with that leading 0 telling you it's octal. Now create a file with touch, then ls-l, and there it is, rwrr, which is 644. Make a directory the same way and you get darwxgar, xrx, or 755. Same umask, two different starting points, 666 for files, 777 for directories, and the subtraction holds in both cases. Out in the wild, you'll really only meet three umask values, sliding from loose to strict. 022 is the default on most personal machines. Files end up 644. Directories 755, group and others can read along. 027 tightens things for team servers, group still reads, but outsiders get nothing. And 077 is the paranoid setting, 600 and 700 owner only. On a shared server, that last one is your friend. Even if you forget to chmod, new files are already locked down. So how do you actually set one of these? You've got two paths. For this shell only, just type umask 077, create a file, and check it. Strict 600, exactly as predicted. When you close the terminal, it's gone. If you live with it for a few days and like it, make it permanent by appending the line to your bashrc. Test first, commit later. That's the workflow. Let's watch Mia put exactly that workflow into practice on a shared dev server. She checks her current umask, 022, creates a notes file, and sure enough, it lands at 644, readable by Tom, Sarah, and anyone else logged in. She flips umask to 077, touches a new file, and now it's 600 just for her. Then she echoes that line into her bashrc, sources it, and confirms 077. One change, permanent protection, no more chmod fiddling. Now here's the trap almost everyone falls into. Reading umask numbers the way you'd read chmod. If you see umask 022 and think, oh, my files will be 022, you're heading for confusion. Same octal format, opposite meaning. Chmod lists what's allowed, umask lists what's removed. So the fix is to always do the subtraction, 66 minus umask for files, 707 minus umask for directories. Higher umask means stricter, lower means more open. Counterintuitive, but once that clicks, the whole system suddenly makes sense. Once that clicks, umask doesn't live alone. It works hand in hand with three friends you've already met. Chmod is the override. Umask sets the default. Chmod edits any specific file afterward. LSL is your verification. Set a umask, touch a file, list it, and confirm the math matches. And bashrc is how the pros make it permanent. Drop umask 077 in there, and every new shell loads it automatically. Default plus override, set plus check, persist plus reload. That's the whole permissions toolkit in one circle. Time to prove it on your own terminal. First, just type umask with no arguments. You'll almost certainly see 022, your invisible default. Then try umask 077, touch a file called t1.txt and list it. You should get RBDO exactly 666 minus 077. Finally, reset to umask 022, touch t2.txt, and watch it land right back at 644. 3 tiny commands and the math reveals itself. And just like that, stage arrow 6 is in the books. You've gone from chmod and chown to sudo su and finally umask, the whole permissions toolkit, from what files allow to who owns them to what new files inherit. Tom's mystery is solved, the subtraction math is yours, and the steepest part of the climb is behind you. Next up, stage 07. Your terminal stops talking to local files and starts talking to the world. See you at ping.